All right, so I was wondering like how to start out. You know, it's always like, how do you start out on a presentation? And I thought maybe it would take a little bit of time to tell you about who I am and my life outside of like my academic world, but also kind of what's important to me in my academic world as well. So I have two kids, Bella. She's 19. She's a sophomore at Pitt. She's studying neuroscience. I'm really proud of her. She's total opposite of me. She is the social chair for her sorority, and I am an introvert that was like a punk rocker. So this is like opposite. I mean, you know, but I love. We have a lot of commonalities. My son Luca, he's a sophomore in high school. He does lacrosse, and I'm really proud of him because he worked all summer and he made the lacrosse team. And honestly, I could care less about that, but it's that he worked really hard and that he achieved his goal. And that to me is really important. And I have the best partner, Doug. I was telling John, he's in Mexico. He works at Little Fuse, and we truly support each other in our careers and our family. Most importantly, though, I have two dogs. Like, they're the most important ones, Hope and Winnie. I got Hope in 2016, and I got Winnie in 2020. And she's definitely a COVID dog, let me tell you. She's very difficult, but I love her I love both of them. This bridge here, actually, we're all on this bridge, has really been an inspiration to me and an inspiration to the work that I do. And this is the Hot Metal Bridge. And so the Hot Metal Bridge was a protected bridge during World War II because so much of the metal that was being produced in Pittsburgh was going across one side of the river to the other side of the river in these huge ladles, if you can imagine that, on this bridge. And so it was protected, and it was a railroad bridge. Fast forward, you know, many, many years, and I was working at a quasi-government agency called the Urban Redevelopment Authority of Pittsburgh, and we were transforming these brownfield sites, like this is now located on, and thinking about infrastructure for new purposes. So I had the opportunity to take this old railroad bridge and make it into a new pedestrian and bicycle bridge that is a key part that connects the trail from Pittsburgh all the way to Washington, D.C. And this concept of taking old infrastructure for new purposes has really been a part of the work that I do and important to me as well. And having my kids on the bridge, you know, after I had worked on it for so many years, and of course my dogs, has been just a really big joy to me. The other thing that I get to do within my life is I spend a lot of time in these two buildings right here, which is the Mascaro Center for Sustainable Innovation. And, you know, I really enjoy my leading the MCSI. And I think the other part that's really important is the Mascaro name. The owner of Mascaro, unfortunately, he passed away. But I really work every day to honor him and to honor his vision and different lessons that he has instilled in me along the way. He was a contractor, but he has worked in green construction for a number of years. So that's a little bit about me. And so I wanted to kind of frame up this talk because I wasn't really sure what I should focus on. So I decided to focus on two different things. And it's the work that I do. So I do work in the built environment, and I also do work in healthcare. And so you might be wondering, like, why these two sectors and how are they interconnecting? How are they interconnected? So this is a figure from Architecture 2030. I really love the graphics that they produce. They're architects, right? They produce fantastic graphics that I think are super compelling. But what this shows you is that the built environment is responsible for 42% of the carbon emissions. So 42%, that's a really significant amount. That also includes embodied carbon emissions, so in the manufacturing of concrete or manufacturing of cement, manufacturing of steel, manufacturing of plastics, all of those, and actually the energy use in the buildings too. Now, healthcare the other thing about healthcare is also responsible for a significant amount of carbon emissions. One of our really great colleagues, Matt Eckelman, and the person that he works really close with, Jody Sherman, who's an anesthesiologist at Yale, they calculated that the U.S. healthcare is responsible for about 8.5% of the greenhouse gas emissions in the U.S. And so in the top left, you can see that calculation as well. So if you put the two together, really, working in the space, the built environment space, and the healthcare space means that I get to do work and really coming up with pragmatic solutions that deal with almost 50% of our greenhouse gas emissions in the US. And one of the things that I constantly think about is we all individually have talents, right? And how can we take our individual talents and have the biggest amount of impact? And again, working in these two spaces is one that I think, I feel really fortunate to be able to do that. And the other thing I say is the people, for better or for worse, so I'm in my school, so it's civil and environmental engineering, so we're combined into one department. Civil and environmental engineers contribute probably the greatest to the greenhouse gas emissions and what we design, the roads that we design, the buildings that we design, the buildings that we operate. But what that means is we also have the greatest opportunity to really think about change and the next generation of leadership in these really important infrastructure systems. And so what we're going to talk about today is kind of what that looks like in those two different sectors. So one of the things, and you may have seen different things, is there's so many people even now, and I actually intentionally included city and university goals, which have not changed in the change of the federal landscape. Individual cities, communities, and organizations have climate and energy goals. So for example, at the University of Pittsburgh, our goal is to be carbon neutral by the year 2037. And you're like, what the heck is 2037? Well, that's our 250th anniversary. Now, people will say that that's our science-based target. In some ways it is, but it's still our 250th year anniversary. So we have this kind of goal. How are we going to get there? We also have something called the Pittsburgh 2030 District. And there are a number of 2030 districts throughout the country. And these are people or business organizations that have committed voluntarily to look at 50% reductions by the year 2030. Over 80%, I think, of the Central Business District in Pittsburgh has committed to that. That's huge. This is voluntary commissions, which I think is really important, especially today. I looked at Purdue. What does Purdue have for their carbon goals and energy reduction goals? And there's in the top right-hand corner, and this is through the facilities department, you have a scope 1 and 2, so not purchases, scope 1 and 2 emissions by 50% by the fiscal year 25. And then I started to go down this rabbit hole of what should it be and everything. And so I just put a question mark there. And then I also, because there's been this growth in Indianapolis, I also looked at Indianapolis to see what Indianapolis was doing. And what I saw was that the Indianapolis sustainability work is really extensive. They have very strong organization. They have strong commitment to different climate and energy goals. And in this particular one, they have a path to citywide carbon neutrality by the year 2050. And so those are the things to do that. But then the question is how do you get there? Okay, and if the built environment is around 40%, if you don't have a strong knowledge of the energy use of the buildings, how the buildings will be changing over time, it's going to be very difficult to really meet your goals in a strategic way. And that's kind of the work that I've been doing in this space. And I'm a big Hobbit fan. So I put this up here because if you're going to be there and back again, we're going to be saying not 2050, maybe 2070 or 2100. And while we would love to live in these great little Hobbit homes, we don't want to be there and back again, right? We really want to think strategically about what we can collectively do in these different scenarios. And so the work that I've been doing in this space, so you see the quote, it says, "A goal without a plan is just a wish." And so because we want to use our individual talents, my view is how can we best support moving from a wish to a plan? That's really what I want to help with. That's really, really what I want to help with, because it's super important. So when I started looking at this urban scale space, I started to say well, what's available? If I was, I used to work in city government, but what information is publicly available to the people that are working in city government that can actually make these decisions, or organizations? What is actually available? Well, let me tell you, it's all over the place. It is getting better, but I would say Pittsburgh's about the middle. Boston has very good data on all the buildings. New York does as well. And so there's all this disparate information. This is an example in Philly. This actually happens to be on vacant property. So pretty good. Philly has good data. This is one from Pittsburgh. This is called Grounded, which is a nonprofit that's trying to do the GIS work, which is a whole nother thing. Why is a nonprofit doing this and why isn't the city doing this? And so what I found was, especially at the time that we were doing this work, is it was a lot of disparate information. So we started on this path. And the path really was looking at how can we pair up urban building energy modeling and climate modeling to help with city scale goals. That's really what we were trying to do. How can we do that? How can we work together to do that? So the next part of the talk is on how we did that. And then along the way, this thing called digital twins came along. And I was well, this seems maybe a little bit easier. So this is work in progress, but I wanted to show you a little bit about the work we were doing there. So the question is really, how can we strategically achieve our built environment climate goals at the city scale? And so there's many different aspects that go into this. And you can see on the right-hand side how we're kind of trying to layer the different aspects to that. So what material stock is available in the buildings? What will the material flow be like when there's renovation or demolition? So we have a layer associated with that. We're also looking at how much energy do buildings use and how does this change over time? And so again, that's what we're really talking about today. And of course, I want to recognize the superstars. For this particular work, Rezvan Ziazi, she was instrumental in this work, and she's doing large-scale energy policy now since she completed her Ph.D. She's been doing great. And I also, Sam was an undergraduate. He's now at Ohio State. And Isabel is now in my lab. Uzal is a professor in New York, and Federica is a PhD student that I'm working with too. And I'll talk about her work first. So this is the start of kind of the data that we had, right? So this is the city of Pittsburgh, and we are looking in this one particular area. And the reason why we are looking in this one particular area is since we are building a model, we need to make sure that we actually have energy data of those buildings so that we can validate our model, right? And so we were able to get the energy data for these buildings during a certain period of time. And also with building disclosure policies, that number is actually increasing. But we're we needed to have the data. So that's why we focused on these buildings. So one of the things that I really stress to students working in sustainable engineering is that we struggle with setting up how we're doing our work. So I always say, pretend like it's a recipe. What steps are you taking so that someone else can replicate your work? And other fields, like if you're doing experimental work, that's common. But in our field, sometimes I feel like I read papers and I'm like, how did they do this? I don't know how, and I'm a visual person. So I'm like, can you lay out step by step how we're actually doing this work? And again, an important part of this is that when we were doing this work, it was the focus on publicly available data. other than the validation, the publicly available data. So I'm not going to go through all the different steps. You can read the paper on that, but I want to stress a couple things that I think are really interesting in this particular work that we were able to do. First of all, in the city of Pittsburgh in step 1, most cities actually have this. It's the GIS data for building footprint. Okay, so that would tell you like, this is the building footprint, and here's the square. Actually, some just have block and lots, which are like these wonky things, and then you have to figure it out. But what we didn't have was the height of the buildings, right? We didn't have the height of the buildings. So what we had to do then was to determine the height of the buildings. And the way that we did that was to utilize LiDAR data to essentially figure out the top of the building versus the bottom part of the building. And we did that for the 220 buildings that were in our sample. But the issue with that, and this is a struggle, and this kind of goes through the different steps in the raster files, is that if you ever see an urban building energy model that has used this approach, all of the roofs are flat. Right? All of the roofs are flat because if you're using LiDAR data, that's really, well here, actually a lot of the roofs are flat. I was looking around that, but in a lot of urban areas, you don't have flat roofs. So it gives you an idea of how there's a misrepresentation right off the bat of some of the issues. But you can always tell if they use LiDAR data because you'll see a bunch of flat roofs, and we call them like shoebox models. The other thing that we then did, and this is the one step, is that we took each of the buildings and put them into different archetypes, or I describe it as like if you have Legos, and if you're like me, you would like sort the Legos by color or different things like that, or by sizes. That's all that an archetype is you like group them together so that you can like make sense of them. So we put the buildings into different archetypes, and then we used Energy Plus to then model the energy use of the buildings. And lo and behold, and this is when you cross your fingers and you're like, oh my gosh, I hope this is right. When you took all of the buildings that we modeled and all of the actual energy use, our model was off by about 7%, which was really good. We were like, okay, I think the one standard says 15%, so 7% was really good. So we felt very, very good about that. And so what we were able to produce is the energy use intensity. So that's the amount of energy per square footage that a building uses. And then we visually displayed that so you can see in some areas where, for example, if it's like a greenish color, you would be utilizing more energy, and you may want to then target that particular area to then look at doing a greater reduction. And to really think about strategically at the whole building stock level what you should be reducing and why. And because we have all these energy models, we also did things like, well, what if we did lighting retrofits? What if we did window film? What if we did increased insulation? So then we can provide that information to the owners of those buildings, and then they can actually say, okay, this is a good strategy for us to work through that. And we have been doing that. So I'm on the board at the Green Building Alliance, and they convene the 2030 districts. And in those monthly meetings, we're able to say, these are the strategies that we have found to be the most effective and what is working for you. But again, without having this overall view, it's really hard to then really hit the 2030 goals or the 2050 goals. We are extending this work with including climate modeling as well out to the year 2100 to then understand how building energy use will change over time as the climate change. But this was our baseline model. As we were doing this, I also started to do circular economy work, and I was like, well, we have all these building energy models. We actually know the materials of most of the buildings, so then we can actually figure out what the building stock assessment would be, and when these materials would be available if we developed a renovation flow. And so we did this next. This visually shows the total in-use material stocks, And so again, in working with the city and working with nonprofits, saying like, this is when concrete would potentially be available. Can you develop a policy to then set aside space for concrete to be reused? These are when the different windows or doors will be available. Can you set aside space to do that? And again, working with them to do that level of modeling. And so this was also put into GIS. It's publicly available, and I've been working with city planning in order to do that work as well. So you know, that's kind of where we're at with that. But along this time, even though I didn't go through all the steps, what I started to see was like, this is really hard, right? Like, there were a lot of different steps and substeps. I'm like, this is really hard work. And the student Federica, she always comes up with different images like this. And so then we're like, how can we make this easier? You know, how can we make this easier? And this took several years, you know, and we've gotten better at it, but how can we make it easier? So then I was like, well, what about these digital twins? Like, this is really how I'm thinking. Like, this has to be like something that could help us. Like, could the concept of digital twins actually help us to better develop our urban building energy models? And how can we take drone technology to actually create the shoebox models that we need to create? And so we're essentially doing the same thing, but we're doing it utilizing digital twin technologies. And we're trying to advance the field and use of digital twin technologies at the same time. And so, again, kind of the same concept. We're working on an NSF project. It's a CLIMA project, and these are the different tasks. And I'm just showing you, this is in progress as well. I'm showing you kind of in green where we're at. And so, because we're still learning about how to integrate all of these different systems, we've focused on one building. So we're like, let's start with one building, see how it works, and then try to scale it up. And so we're focusing on the left building, which is the Mascaro Center building, because we have a lot of data on that. And so, similar to what we did with the urban building energy modeling work, we laid out the schema. Like, what do we have to do in order to do this project? And I'm going to work through some of those components today. So, hold on. So the first thing that we did, The first thing that we did is we created a building information model. Okay, and so the building information model is in the lower right-hand corner. Newsflash, almost every university should have building information models on the new buildings, at least, that they are constructing, and that's an underused resources by researchers because it took us so long to develop this building information model. So if you can create that relationship, I really can help you. But the reason why we needed the building information model was because if you do life cycle assessment research or material flow analysis research, the building information model helps you set up your bill of materials, right? It helps you establish how much concrete, how much steel is in the building. And so this is really the part of the work that we did. And again, we did a very high fidelity building information model. When we did the building information model, because we knew this was going to eventually go into a digital twin, is we actually used something, a Dynamo script that was developed by Stefan Bilec, so that when this stream of information would be available, it could then connect to our digital twin model. So we extracted the building information model, or the bill of quantities, into this Dynamo model. So that is the second step. And then the third step that we did, and we'll kind of do this together, is we then exported our building information model into Energy Plus to do the different analysis. And you think it's going to be magic, like you think, but it is not. There is a lot of fitting. It took us a tremendous amount of time to do this kind of conversion and figure out the best way to do this. And what this is actually showing is how the different rooms are actually modeled in different volumes in the Energy Plus model. And then at the bottom of the screen, you can start to see the actual energy use of in this particular building, it's the Mascaro Center for Sustainable Information, and that's the energy use. So a little more to kind of see what's going on. Well, and it's nice to have a video to like catch my breath a little bit. Let me show you. We're working through the energy model again. Okay. All right, I'll advance it. So then what we did, now we have the energy model. So once you have an energy model, you can actually do predictions. But the next thing that we did was to set up the material flow analysis for that particular building. And we also did the greenhouse gas emissions for each of the different materials, which you can see in the bottom right hand of the corner. So essentially what we're doing is we're trying to get like all the different pieces of the puzzle so that we have this really unique data stream that can go into the digital twin. So we have the energy analysis, we have the material flow, we have the greenhouse gas emissions or any sort of the life cycle impact assessment results, all kind of like priming up in order to do this. And then what we're starting to do is to figure out how we can start to display this information in a meaningful way so that the people in the building can make decisions, so that the university can make decisions. And instead of seeing like those really lame, and they were lame, greenhouse gas, figures over time, which honestly, people don't make decisions based on them. How can we take that information, put it into something that's visual, and also, this isn't just a fancy picture, it will be connecting the data that we've already set up as well. And so, this again is a work in progress. I'm really excited about the work that's happening. And let me show you one other data visualization. Well, actually I have a couple more. But this particular one I think is also kind of cool. Hold on. This one might be similar. Oh, this is why I wanted to show this. So you can see the green boxes on the right. You saw the green boxes on the right-hand side. Eventually, what we're doing, and I was actually just talking about Federica, is now that we know how to largely do this in the Mascaro Center, how can we apply this to the other buildings across the street so that we can then scale it? So our goal with her PhD is to do this building and then a portion of the streetscape to start to demonstrate how this will happen. And the cool thing will be to see the interconnectedness between the buildings, right? How the electricity use between the buildings, the flow of materials between the buildings as well. Okay, so what Federica right now is working on is setting up, they're called building automation systems. And so every university has building automation systems, and they have information like, in this particular case, the air humidity in every room, the temperature in every room. We have actually air quality data in every room. So we're connecting the building automation system data to our digital twin model so that we can better understand what is actually happening. And instead of having like this wonky 157A, which nobody means, if you have it in this much nicer visualization world, can there be more visualization and decision making that's actually happening? This is not a trivial process. It is very difficult. You think you have like this beautiful building automation system data, but it's a mess. The data is truly a mess, and quite honestly, we're really struggling. We're struggling with cleaning the data, getting the data, and everything like that. But ultimately, what we hope to do is to have people have information on their spaces. Again, so you can imagine like clicking here for information, and then perhaps you'll have things like, okay, this is my temperature, or what is the airflow in the particular space, or what is the floor plan? Is that room occupied? Is it not occupied? To ultimately help with efficiency. And then you can imagine displaying this information external to the building so that you can start to understand what is the carbon impact of this building? What is the energy use of this building? And could you maybe even set up some different like gaming strategies and thinking about like having competitions amongst different dorms. So for example, we hope to display the greenhouse gas information, the material stock information, kind of all in one place. And so we have done this for, again, the one building. Our hope then is to scale this to a much bigger scale. And so again, our plan for this particular one is to really support the university and the city of how to move from a wish to a plan. And I put Purdue's back here to maybe encourage you to do the same. Fortunately, I'm on Pitt's Climate Commitment Committee, so I really do get to understand what the plan is, like what the actual plan is. And we just submitted a paper that looked at providing recommendations for each of the buildings that we looked at to then say what those reductions need to be and what they should be. And so it's been really great to really have impact and to work with a team. Okay. Deep breath. So that was our building talk. And now we're going to switch to healthcare. So another trip down memory lane. And John, you may notice some people. This is like one of the superstars. This is Cassie Teal. And I had the honor of being her Ph.D. advisor. And she's done amazing work. But this is one of the first times we went into a surgical suite. We were called bunny suits. We were putting on our bunny suits. And yeah, there's Cassie right here. Actually, this is interesting, maybe kind of gross. We had to figure out the electricity use of this trocar device, but because there was variability in how it was used, we broke into the OR. Not really, but it felt like it. And we had our different electricity monitoring devices, and we were simulating the electricity draw, and we brought chicken because it's kind of like skin. So those are like pieces of chicken that we were simulating on, and that's like the most surgery I'll ever do in my whole entire life. And in the upper right-hand corner, I'm going to talk briefly about one of those studies that we did. But we did waste audits on, I think it was between 60 and 65 of different hysterectomies, the waste that was done. And that was, we were literally on the loading dock at McGee Women's Hospital doing the waste audits in full PPE, and you can kind of see those pictures over there. And it's been a really great and fruitful collaboration and interest. But if you're interested in healthcare and trying to think about like what does the system look like for healthcare, you would have any sort of material acquisition, and with that comes different types of pollution to air, water, and soil, hospitalization, utilization of resources and materials, waste disposal, and other things. And so I came into this world with like my LCA background, and when you say life cycle to a doctor, very different than a life cycle assessment that we think about. When you say end of life to industrial ecology crowd, that is one perspective. But if you say end of life to a doctor, very different perspective. And I say this because like the vocabulary is so interesting. And that's a part of working together, and a lot of times it comes down to vocabulary and understanding and trust. The other reason why I started to do this work was, as you know, the Hippocratic Oath for clinicians is to first do no harm. And my colleague, Noe, who I had worked with, said, I am like, she's a total hippie. When she first got out of it, she worked at a Navajo reservation, and she was an OBGYN. She was the only OBGYN delivering all the babies, and she lives a very sustainable life, but she would go and put her OBGYN cap on, and she didn't even have the opportunity to think about waste reductions over time. And so she's like, how can I do? And she knew that she was actually contributing harm to the environment and also to public health in the systems that she was operating in. And so she wanted a way to save that. And so she came to me and she said, you know, this isn't my child, but she was delivering a lot of babies. And she said, look at this beautiful baby. This is the waste from the birth of one baby in the US. One baby, traditional birth. And it really hit me. I was like, holy, this is crazy. This is so crazy. So I want to honor the work that, and the inspiration that Noe has been to me. And at the same time, you know, I was working in the built environment space. I was seeing work being done on transportation systems, you know, and fuels, different efficiencies of appliances, and different bio-based products, but there was nothing being done in the healthcare sector, nothing, even though we know that healthcare is about almost 20% of our GDP. And I was like, we're never gonna hit any of our goals if we don't start engaging the healthcare sector. And so I was like, okay, this is intentionally fuzzy. I was like, well, we'll do green facilities, we'll do like and we actually did all these different things, you know, about 10 years ago, but this was kind of, in my mind, how I was like framing the discussion in the healthcare world. And so I started down this path, okay, of doing LCAs, like LCAs of birthing babies. So what's the comparison of a cesarean section versus a traditional birth? That was fantastic. That was like one of the first studies we did. And then we started to do, okay, well, we see this thing called the robotic surgeries. Are these worse in terms of environmental emissions compared to laparoscopic surgery or abdominal surgery or vaginal surgery? How do we compare and how do we help people make decisions on the different types of training and infrastructure that we do? So we did the 60 plus, investigated 60 types of laparoscopic surgeries for hysterectomies, which is the #1 surgery for women in the US. And we found that for the greenhouse gas emissions, the life cycle greenhouse gas emissions for the robotic surgery was significantly higher than the other types of surgery. And a really important part of that is anesthetic gases. So anesthetic gases are extremely potent greenhouse gases, and most of the times they are vented into through the HVAC systems in buildings. And so then we finished that study, and then I started to be like, well, what's next in our LCA world? And so we started to do a PAC study. So if you aren't familiar with a PAC study, if you've ever been into the hospital, and there's 51.4 million inpatient procedure annually. Anytime you go in, there is a PAC ready for you. So in this, I mean, there may be 2 things that are used in this PAC. There may be, you know, all the things that are used in the PAC. And these are developed by the clinical groups. And it's there to be efficient, right? It's there to be efficient and to help people be efficient, but everything gets thrown away once the PAC is open. And so with so many different inpatient procedures, it's a tremendous opportunity to think about reducing resources and also cost. So we started to do work. I actually love this paper. It's one of my most favorite papers that we did. Then fast forward a little bit more to today. We did an LCA of an ALC. Okay, so you don't know how many times like I messed this up. And so if you've ever had, it's an ACL surgery. Actually, my daughter went through an ACL surgery playing basketball. So this like really hit home to me. It's actually really common in girls in sports, especially basketball in the US. And so we did an LCA surgery. We did an LCA. So anyway, we did an LCA of that. And I worked with, his name's Freddie Fu, who revolutionized knee surgery in the US. And he said to me, and he passed away like 4 months after I met him. And he said, I thought I knew everything about LCA surgery, and now you're going to teach me something new. And it just warmed my heart so much. So I did this work, and it really in honor of him. So we completed that surgery. But very similar, very similar to the path that I was on in buildings, I found out, lo and behold, people have carbon emission goals, but they don't have a path to get there. They don't have a path to get there. So in England, the NHS they have a strong sustainability program. On the left-hand side is their pathway to net zero energy. On the right-hand side is the different healthcare organizations have pledged 50% greenhouse gas reductions by the year 2030. And I was just listening in on the National Academy's Health and Climate Talk, and one of the things I can report to you is nobody has pulled that pledge. Everyone is still honoring that pledge, which I thought was which was really good. But what you will see here in this space right here is medicines, purchasing, and supply chain. One of the biggest parts of the greenhouse gas emissions associated with healthcare. And so what we are doing is actually focusing on, a lot of this is plastics. Like a lot of it is single-use plastics. So what we are doing is working with the University of Pittsburgh Medical Center. They also have that pledge to guide them in thinking about how to reduce their plastics. And so this right here is a screenshot of the sustainability initiatives. And you'll see here they have carbon reduction goals, the same thing, they have that pledge. They have supply chain goals. They have, I try to look at environmental service goals. But here's the thing. Everything in the medical community is in dollars, okay? UPMC has they don't even really know the amount of waste in tons that they are doing. So what we are doing is we have set up and working with their supply chain team a material flow and material stock analysis of the plastics using their supply chain data to then ultimately talk with them about how to do the reductions so they can really meet their sustainability and climate goals. And so what we've done is we've gotten a lot of the data, and this is where relationships are important. Like, I know the Chief Medical Sustainability Officer. I know he's on that team. Like, these are long-term relationships so we can actually get that data and build that trust, and they need our help. They really need our help. We're developing circular economy interventions, and then we're providing those recommendations. So I'm going to walk through a couple of those today. The other part that's really interesting is we are looking at 4 different facilities. And the reason why we're looking at 4 different facilities is because, as you can imagine, going to like a really big healthcare facility that has a lot of medical training is very different than actually going to like a super efficient outpatient center. And so UPMC is in particular looking at where should we be more efficiently be training and treating patients. So this gets into a little bit of a nuance, but it's really important for reducing costs and efficiencies in healthcare systems. So how we went through and did this is we got the data for the 5 different facilities for the year 2024. And of that, there were about 44,000 products or services, which translated into 278 million different items. So then what Natalia did, and Natalia's I need to say that, Natalia's the person working on this, she's amazing. She took each of those different items, and then through different techniques, she determined what the weights were of those individual items. And that's not a trivial matter. And we are working with computer scientists to increase the efficiency of that process. But essentially, an example would be blunt fill needles. She would go to the websites and see that it was like 1.09 grams, and then then she would do a material characterization of what is the most likely plastic resin made out of that. It's not perfect, but this is kind of where we're at. So what I'm able to show you today is our baseline preliminary results. And what we're able to do is to show the total plastic mass at the 5 different places that we looked at, and also the associated carbon footprint of each of those individual hospitals. So for example, Presby is the highest, okay, and it's really, really high in the amount. But Bethel Park, which is actually really close to my house, is really low. Now, this isn't a hospital, but they work very efficiently, and the number of procedures they do is actually really high. So there's a discussion on, do you go to an inpatient or outpatient center, or do you go to sometimes you don't have a choice. And then the associated carbon footprint, which helps UPMC get to their goals. The other thing that we did, and I know you can't see this, but trust me when I say, we looked at the top 10 plastic products by impact at all 5 facilities. And we found that in every single case, the surgical gloves, exam gloves, and blood tubes were the highest. So the recommendation then is, if you really want to focus on things, how can you focus on these top 10 areas that can lead to different reductions? Because people want to make decisions, right? And the people that we're working with want to make quantitative decisions that actually to drive their success. So what we're doing next is we are working with the Clinicians for Climate Change Action, which is a part of UPMC, and we've set up a workshop, and we're working with them to come up with, these are the things that are in the literature, circular economy strategies that are recommendations. Actually, we just published a paper on this. But we need to hear what you think will actually happen, get consensus around those ideas, and then work together for the implementation. Because at the end of the day, what we don't want is to have our research not have impact. I don't want that. You know, I'm too old. Like, I really want to have impact in the work that I'm doing, and you know, I really want to try to best use my talent to really support some of the biggest challenges that we are having. And I feel it's really an honor to work in these 2 sectors. It's something that I think about a lot. And I want to thank all the talented students that I've had the opportunity to work with. Every student, I say this all the time, I say, I get to walk your PhD journey with you. I'm beside you. And at the end of the day, it's your PhD, and it's your life, and it's your career. And it truly is an honor to work with such talented people. And that's it. Thank you.
I think we have time for a few questions.
Okay. Hi, sorry, I'm really not in this field, so
That's okay.
the question is not so sophisticated, but just so I have an understanding, you mentioned this analysis that buildings do, I guess, when they first put the building in place. Is that correct? Like a very comprehensive assessment?
So the building information model, or which part of the talk? And maybe I can.
I think it was, yes, this one where you were mentioning that they had new buildings, and then every time you have a new building, they would have this really comprehensive analysis for these new buildings. I guess this.
And I think so. Thank you for your question. Yeah, and I so let me try to. And if I'm not answering it right, we could talk.
Oh, but I have a follow-up question on this, I guess.
Okay.
So so they do this comprehensive assessment. Is that correct?
So what most engineering and architectural firms will do is they will create a 2D CAD drawing, okay? And depending on the client, which a lot of universities are clients, they will require also a building information model to be done, which is essentially like a 3D picture of the 2D model. And so that model is typically stored somewhere on campus. Like that, I actually had a student try to intern with facilities to try to find them. I did. But so this information is for the designers and contractors to actually build this building, but then it's also used as a historical record too.
Oh, okay, so I'm curious about this, like, energy analysis section. So they basically, I guess, make an assessment about how much energy use would likely occur
Yeah.
during the building usage. I'm just curious, like, what components of the building typically fail? Like, they have a predictive model for assessing energy use. What are the typical things that would break down in a building? Like, I'm gonna guess HVAC systems, or maybe something else that I don't know of that would really make the whole system go awry.
Yeah. So that's a really good question. So here's what, so essentially we're creating energy models, okay? And an energy model could be this, when we design structural systems, a lot of times we're designing, using different structural models, so and I don't know, or an environmental, like a waste treatment plant, that's a model too. So this energy model is typically for the whole building, and it has, hundreds of variables. Really what you're trying to figure out is the heat flow and the associated heat loss that's happening in the building. Where I see, and actually we have figured out how to model that pretty well. But also what's included in that is the occupancy, because we actually bring heat into the building, and the schedule, so when people come in and out of the building. And those two things are where I think the energy models have failed the most, in occupancy of the building. The other one that I see too is like plug loads. That's another one where I've seen the failure occur. But for any LEED rated building or green building, you are essentially required to do an energy model. At the University of Pittsburgh, within our specifications, they have actually energy use intensity performance requirements, which I think is actually really, really good. So the designers and contractors have to say that the building will actually perform at or below an energy use per square foot. Hi.
Hi, Melissa.
Hi.
Thank you for the great presentation. So for the healthcare system, you focus on the material use. I'm wondering, do you see opportunities at the intersection of the two in terms of the energy use of hospital buildings? Because based on my limited experience inside a hospital, like patient room, it's so cold.
It's so cold. It's so funny. I started to the one slide I showed was like the facilities slide. And I started to do that in the presentation. I'm like, I can't add any more to the presentation. But you're exactly right in that there's intersections with buildings and health. Hospitals are some of the highest EUI. They're actually one of the highest EUI energy use intensities of any type of a building. And so this is what I have found, is that, and this is true throughout many, and we saw this in COVID as well. Actually, I was just talking with someone, Lindsay Marr did great work, is there are standards that have been put in place where it's like, we have to have this temperature so that it reduces the infectious rate. Okay, and that's true, especially in the ORs. But a lot of times, that is not based on science. It's based on literally somebody saying years ago it should be about 65 degrees or something like that. And I think one of the things that we need to do is to challenge, is this based on science, right? Is this actually based on science, or is there microbial growth? Is this increasing the infectious rate over time? But I think there's a lot of rich work that needs to happen within that space, and how those two can go together. And ultimately have positive patient outcomes, improve patient outcomes, which is what we want.
Other questions?
Thank you for the presentation, Professor. I found it very interesting, and especially the different areas that you're focusing on. So,
Do you hear Teams calling me? I actually put it on Do Not Disturb, so I'm sorry. Go ahead.
my question was on your first area with buildings. So you had mapped the heights of the buildings and also looked into the energy consumption
Yeah.
of different buildings. So there's going to be a lot of variation in energy consumption throughout the year and also
Yeah.
monthly and weekly. And it's not going to be the same every year
Yeah.
as well. So I saw a plot where you had like predicted versus actual values for yearly data. They were pretty close. Did you, because of the type of variation, are there some methods that, based on your experience, you have in mind where they can be widely implemented to reduce the overall consumption to some extent? So if someone doesn't have access to do this level of detailed analysis for
Yeah.
a specific building, will they still be able to have an idea of why the energy consumption is higher in certain regions, or depending on if the building is directly next to a lake, then they might need more heating to keep it warm in winter.
Yeah.
So are there any methods that you've come across where we can account for these in general?
Yeah, so thank you for the question. And I think what's really important to that is like what is happening on the ground to like what is actually happening in the buildings on the ground for people that are making those decisions. And I think we should all keep that in mind in the work that we collectively do. So what I would say is that there's different, we call them like they're called like ASHRAE zones of the country. And within those different zones for type of buildings, the Department of Energy has come up with strategies to actually look at what you should do for reductions for different building types as well. What I have found though is that microclimate is so important within this work. And so I would encourage us all to like listen to what the operators of the building are telling us and actually do that implementation, because it's people that are working in the buildings and living in the buildings that really can I think lead to some of the really important results too.
All right, thank you all very much. Let's thank Professor Bilec once again.
Thank you.